Hey boys and girls, welcome back to Munro Live. I'm here with Tom Prochet, and what we're going to do today, or let me rephrase that. What Tom is going to do today is give you a little lowdown on what we've discovered so far on the 4688 battery pack that's inside of the Tesla Cybertruck. So I'm going to give you the one thing that I was kind of curious about or interested in, and then Tom will take it over because he's the expert. So if we look down here, when we peeled off the, so we've got mica here and we've got the green stuff there. And even though this is only three something volts, I don't touch anything. So the one thing we can look at is that little ball bearing down there, which basically is the blowout. As far as I'm concerned, if that cell goes bad, it has to vacate the gases that are inside, and so it blows that little thing out. On the other ones that we saw, it's got a pop rivet, for lack of a better word. And you can notice too that there's some configuration down here that we haven't seen before. Today's video is sponsored by Wiegel. Hey boys and girls, welcome back to Munro Live. I'm here with Aaron Wiegel from Wiegel Solutions Manufactured. And believe me, I'm sure this is going to be a great tour. Anyway, Aaron, can you give us a little background, little something on you, and tell us a little bit about the company?
Sure. Thanks, Sandy. Aaron Wiegel, President and CEO of Wiegel, formerly known as Wiegel 2 Works, and we just recently dropped that acronym because of all the different capabilities that we now offer our customers. We're a third generation owned business. My brother, sister, and I are the third generation. My grandfather started it back in 1941 as a tool and die shop, and over the decades and generations we've evolved from a tool and die shop to a metal stamping facility to now just doing a lot of different manufacturing with the stamping emphasis. Today we do a lot of patented roll welding processes, assembly processes, and we're into molding now in somewhat cases. So just a lot going on here because we want to make sure that we are providing everything that the customer is looking for as a one-stop shop place as we start to grow and add on additional capabilities and expand our footprint, not only in Chicago, but now heading into Mexico in 2024. This is a patented welding process that we co-developed with two other partners in the United States to be able to produce the products that we're making for our customers. Custom machines, and we're about to show you a little bit of what this thing does, but as an example here, we're marrying two different aluminum materials together to produce a welded component here. So here's the after and this is the before. So as you can see, the parts are being moved from station 1 to 2, 2 to 3, 3 to 4, and then the robot will introduce a new piece here, and that process will continue as we start the automation process. So the robot to your right is locating the flexible circuit board, removes the backing to expose adhesive, use a vision system to check whether or not it's a positive or negative flex circuit board, locates it on the frame, applies it. So this is empty tray. So once this is full, it'll come out. Yeah. We put a top on it, and that's the final stages where it's the operator's responsibility to get a full skid out and keep always an empty trays of a full skid ready to go in queue.
So anyway, what we're looking at is one of the pieces that's coming out of this minster here, the 160 ton thing. So we're looking at I don't know, some sort of a connector or contactor, and this is like amazingly thin.
Over here, this is our 350 ton minster. And what we're stamping out here is a thin gauge, well, I would say medium gauge, copper-based material with tin plating once more, and this is a thinner gauge bus bar.
Where is that done? On this press?
So we have a post-operation on this particular part where we're putting PEM insertions into these parts. Some of that can be done off press, and some of it can be done in die. So we have both applications. really, if you're going to do it in die, it really depends on the part design, which may or may not allow us to be doing it in die. So welcome to our wire EDM department at Wiegel. So this is really part of the process of how we make all of our progressive dies within our facility. Everything is all designed and built at Wiegel. And as far as the precision and where the most important part of the process is when it comes to making our tools, starts right here. This is a climate controlled room, 68 degrees once again year round. All these are MITS brand wire EDM machines. Typically we like to flip our machines every 5 to 7 years because the technology on these machines change so quickly and just they so much improve, whether it's just the speed of the machine itself or even the wire consumption.
All right, well, I have never seen one of these.
Yeah, I'm not surprised.
Well, this is brilliant. Aaron, I've had a hell of a good time. I gotta tell you, and I don't get stumped too many times. You got me twice. So I'm really impressed with all the stuff you've got going on here. I've just had an amazing afternoon. This has been really, really wonderful. So thank you very much for allowing us to come here and basically videotape all this stuff. Thanks for educating me on a couple of new techniques I've never seen before. And just in general, this has been brilliant. Thank you so much.
Well, thank you, Sandy. I appreciate you coming on. I appreciate you coming and seeing what we got going on here. I mean, our family and our staff are really proud of what we've accomplished. And to be able to showcase that is great. So, and especially on your show, it's been... got a lot of notoriety, and we feel proud and that we can even be here. So if you want to find more information about Wiegel, it's www.wiegel.com. And again, thank you for everything from my family, to yours. Appreciate it.
Thank you so much. Thank you.
Thank you.
And ladies and gentlemen, boys and girls, thanks for watching. Stay tuned. There'll be more coming up in the near future. Bye.
Okay, so down on this end, we've started to extract some of the materials so that we could get to the back sides of the cells. By the back sides, I mean the anode end where these vents are, Sandy just showed you. The first thing we wanted to understand was how the pack was organized in terms of S's and P's. So that was a relatively simple process. You'll notice I'm very minimally PPE'd here today. That's because we understand this pack very well right now. We know exactly where the potentials are that are lethal, if you will. So I know that I'm working with 3.4 volt range here, and there's nothing I can do to get myself in trouble. So that said, what I want to do is just quickly show you the open circuit voltage of one of these cells and show you how you determine that it's a 7P, I'm sorry, yes. 7P arrangement. So pretty simply done, I just take the voltage between two of these, and if you look at the voltmeter there, it's 3.39 volts. So if I start probing around here, I can determine things pretty quickly. For example, yeah, this one's the same, this one's the same, this one's the same, this one's the same, that one's the same, and so is that one. So relative to this one cell, they're all at the same voltage relative to one another. All right, so that said, if I probe around further, it's pretty easy for me to infer that each row of 7 is wired in parallel. So again, if I just use deductive reasoning here, I can figure that out pretty quickly. So the next question is, okay, if I know that it's a 7P arrangement, how many do I have in series? So I've previously done a measurement and come up with 325.2 volts, I think it was, which is what I would call the voltage of the half pack. So when we removed the penthouse equipment, one of the things that happened is the connection between this side of the pack and that side of the pack has been opened or separated, if you will. However, on the far side, there's still a bus bar that interconnects these two. So this entire array is still electrically connected to this entire array. And in total, that amounts to the 325 volts I mentioned. So that being the case, I can go right underneath there if I untape the terminals and I can measure that voltage. So if I take that voltage and I divide my 3.39 into it, I end up with exactly 96. And 196 is the number of cell groups in series for half the pack. And if I multiply that by 2 for the other half of the pack, I get 192. So yes, the configuration of this in terms of S's and P's, as we like to say in the business, this is a 192S 7P pack, totaling out at 1,344 cells. So pretty straightforward when you have an understanding of what the parallel arrangement is and you know the total voltage involved and the individual cell group voltages. We're thankful that the battery management system does a good job and each of the cell groups are relatively close to one another. So when I measure 3.39 on one, I'm confident that it's 3.39 on all of the others as well. So if I go out to a third digit, it's going to vary a little bit between the different cell groups. So that said, voila, we know there's 1,344 cells in this pack. But what I also wanted to do in this video was kind of contrast what we've learned here on this pack to what we knew already with the structural pack from the Model Y. So it was our previous experience with this sort of encapsulated battery pack, and there's a number of differences that might seem subtle but are very meaningful for us as we try to take this pack apart. So come over here and you take a look. I'll point out some of the similarities. Obviously these are 4680 cells as well. They have what appears to be a nearly identical, if not identical, cooling pipe that goes in between every other row of cells. So this cooling channel here has a serpentine path through each of the cells that are in these two columns. So the same for this one, same for that one. Now what's unique about that is that I have 6 columns, I have 3 cooling pipes, pretty straightforward. I run right down the middle of 2 columns of cells. So what's different about this though, and it's kind of hard to see from this arrangement, but what we have is a 9P in the Model Y. So 9 cells in parallel, which means that even though I've got a row of 6, that means that one row of 6 is combined with the next row, half row of 3 to create the 9. And then I still have a half row of 3 for the next row of 6 to make 9. So it's 6, 3, 3, 6, 6, 3, 3, 6, all the way through the pack. You can imagine then if I was extracting cells from one row, I have to be concerned with the fact that I'm still electrically connected to half the cells in the next row. So it's quite a bit different with the new pack here from the Cybertruck in that at least each row of 7 is autonomous by itself. I don't have to worry about interacting with the next row as I'm working on a single row. So I don't know if that makes a lot of sense to everybody, but it does to me. So that's what matters as we try to take this thing apart. So this is, where the similarities end. This pack is right side up relative to the way it's installed in the vehicle. This pack is upside down relative to the way it's installed in the vehicle. That's because in this case, the cover's on the top, and in this case, the cover's on the bottom. So we had to flip the pack over. But what that means is that all these current collectors that you see here are buried in the bottom of that urethane where we can't see them. We had the luxury in the case of this pack where we could blast away. We used a dry ice blaster if anyone wants to go back and look at those videos. By blasting away, we were able to get to the current collectors, disconnect the cells one at a time, and then extract the cells one at a time. We don't get that luxury with this one unless we do some rather invasive surgery that we'd like to avoid.
Well, we are.
Well, it's already pretty invasive,
yeah,
but
right.
it could get a lot more.
Yeah, I think that what we're probably going to do is try and cut away some of the shielding and whatnot, the battery tray, as it were, and see what we can do about removing some of them. But I'm very doubtful that we're going to be pulling out a whole lot of these batteries. These are really, they're tough to get at, and the cost would be astronomical. So we'll have enough for our own testing, but I doubt very much we're going to be selling a whole lot of these.
Well, I was going to stop short of giving away our detailed strategy, but you heard it here first.
Yeah, well, that's our strategy for now.
There are a few more details, but yeah, generally speaking, we have a material we're able to break through the polyurethane with. We assume it's polyurethane until it's tested. that's because this was a polyurethane material, and we believe pretty strongly that the big difference between the two is one's pink and one's kind of the blue-green color you see. So,
well, that's the latest.
It's
From the
the
color
latest.
console,
Right.
they've kind of gone to sea green here.
and we know historically they've always changed the color slightly between different models and vintages of modules. So, you know, Model 3 is slightly different colored than our Model Y, slightly different colored than the Model S. So, all that said, other things that are similar yet different, there's a vent trough here in this pack as well, but it's comprised of these black trays that you see here.
Here, let me
We've
grab
pulled one of
these.
these black trays out just to show you what it looks like. And what you'll notice about this tray is that it's pretty frail stuff, right? It doesn't support a lot of structure. Its intention is to provide a spot to route the flammable gases out of the pack during a thermal runaway event. It serves another secondary purpose, if you will, that is very important, and we saw an example of it on the other one I'll make an analogy to, but if there's a road hazard, a rock, a pothole, a trailer hitch, whatever.
A boat anchor like
a boat
they did
anchor,
hit.
yeah, exactly. It can hit the bottom of the pack and impinge on the pack, and what you want is a sort of a buffer zone for road hazard safety. So you don't puncture a cell because you had something that protruded into the bottom of the pack. So that being the case, they've given themselves, probably close to 1 inch in total when you stack up all the materials of buffer zone for this passenger car that's meant for the public roads.
Yeah.
If you go to an off-road vehicle that's meant for stumps and rocks of every type, that buffer zone's got to be bigger. And that's why you see that's such a big space here. All right, so it is serving that same purpose as the vent trough to carry the gases out, but it's arguably a little bit more volume than you might need for that. Yet that extra buffer for road hazard is really important for an off-road vehicle.
Well, this one actually even has more because the skid plate on the bottom is actually raised as well. So this is about 2/3 of what you're going to see. It really comes up to about here.
I think you
where
mentioned about 30 millimeters
Yeah,
or so in
yeah,
total.
right, yeah.
So that sounds perfect for me.
Yeah.
You know, but the mystery about couldn't they have filled this up with more cells? Well, you know, probably one of the things they could do with a major retooling is they might be able to go from a 4680 to a 4695 or one of the longer cells. However, they really like that buffer zone. And for that matter, they really like the space that they have to carry the gases out when there's an event. So that being the case, it's not like you're going to put another row of 4680s or another stack of them or anything like that, not without impinging on either the passenger compartment space or your ground clearance of the vehicle. So yeah, those are two pretty coveted parameters as well, so you're not going to see them try to do that. So that said, yeah, I'm not going to say they can't add capacity to this. We look at these long troughs here that are empty. Another comparison with the Model Y structural pack is that we had the same sort of troughs here, but they were filled with this black sort of really energy absorbing foam. And I assume that that served both an NVH purpose as well as a side impact energy absorbing purpose, but you know, it's a guess.
Well,
that we
these
make when
things,
we reverse engineer.
yeah. This doesn't really, I don't think this is going to be much of an energy absorber because I can squeeze it. And if it was going to be, you know, like EPP or something, expanded polypropylene, that's something that was in here, okay, but this, not so much. And this is expensive.
And you'll notice it's missing in action on the Cybertruck, along with the plastic tray.
Yeah,
now, this thing was eliminated pretty simply with the simple idea of flipping the pack over and just using the void area instead of the tray.
And I like this better because this gives me more volume. If one of these things do blow, it's no big wow. If you get maybe one parallel pack that all of a sudden, for some reason or other, wants to, okay, now I can exhaust all that gas because I've got so much area here. It's incredible. So I like the idea of this. Plus it protects, it's going to make it tough for us, but it protects Tesla's battery integrity. I mean, it's going to be difficult for us to tear this thing to pieces and expensive.
This is kind of a subset of my favorite spreadsheet some of you might have seen in the past. but it is a contrast between the two different approaches to the packs. You'll notice that the Model Y structural pack was a 92S 9P, where this is a 192 7P. The total number of cells is drastically different between the two packs. We had 828 in this unit, and now there's 1344 in this one. So again, that also is shown with regard to the voltage operating range. There's quite a difference. This is a 400 volt pack and this is an 800 volt pack. Again, a very gross generalization the industry uses. That doesn't mean that it's ever really 800 volts exactly, except for maybe a brief moment in time. Yeah. It's really approximately 537 to 806 volts in voltage operating range, compared to the old one that we were already very familiar with at 257 to 386 or so. So again, it's a doubling of the voltage. Another unique feature of this that has been touched on by other people, I mentioned the half packs. This particular pack has the unique ability to reorganize itself. It's 800 volts as a normal situation, but it also has the ability to reorganize itself into two 400 volt packs in parallel. And that's important because the charging infrastructure is mostly 400 volts in the United States. So if you want a DC fast charge, your only way to do that with this pack, unless you have the lucky chance of having a real 800 volt DC fast charge station, is to charge at 400 volts DC, and by reorganizing the pack as a 400 volt pack dynamically, when it encounters such a charging station, we have the ability to fast charge this, with the obvious ability to fast charge better if you encounter a real 800 volt charging station. So kind of unique. We've seen that feature before on the Hummer. Kind of works in reverse, where that's a 400 volt pack, and when it encounters an 800 volt charging station, it can reorganize itself as an 800 volt battery instead of the two 400 volt batteries in parallel that it is now. So anyway, two different approaches to the same exact sort of idea. We'll be touching on how Tesla does that differently in a future video. So for now, know that they're similar and sort of opposite in the way they work in that regard.
So just out of curiosity, we haven't taken apart a Chevy Silverado. Now that has an extended range. Is it 800 volts as well? Does it reorganize similar to?
I am not as surprised on the Silverado as I am the Hummer. If it's the same as the Hummer, then yes. It can be 800, it's normally 400.
Anyhow.
So there you have it, everyone. That's, again, most of what we know. Stay tuned. There's a lot more where this came from.
Absolutely. Thanks for watching. Bye.